Let's look at something a little bit different now. So now that we know how to find our excess reagent and our limiting reagent, we want to look at how to find percent yield. So in this equation we're trying to find out what is the maximum amount we could make of something, and then what is the actual percent yield. So we're going to look at that in just a second. Our question here says that we have 30 grams of C3H8, which is burning in air. And anytime you see something burning in air, that means it's burning with oxygen, to produce 70 grams of CO2, that carbon dioxide. So we've been asked to calculate the theoretical yield and the percent yield of that CO2. So what is theoretical yield? The theoretical yield is just that maximum amount of product that we could make under ideal conditions. So assuming that we are able to use up all of our reagent to produce the absolute maximum amount of our product, we would get our theoretical yield. So let's look at our equation. We have C3H8 plus oxygen, and again that's just because it's burning in air, and we are getting CO2 and H2O. So this sort of equation should look familiar. This is a combustion reaction. Anytime you're burning something with oxygen to create carbon dioxide and water, that is a combustion reaction. So if it is burning in air, we can assume that we have an excess amount of oxygen. It doesn't matter what number you put, you have that excess amount. So we're going to go ahead and balance this equation. Notice that we have 3 carbon on the left side, so to even that out, I put this 3 on the right side. But notice that then gave us this 6 oxygen plus some more from this one. So let's take a look at this again. So we have hydrogen has an 8 on the left, and it only has 2 on the right, so I put that 4 there. So now let's look at the total amount of oxygen on the right. We have 4 from this one and 6 from right here, so we need 10 total. So you just put a 5 in front of that oxygen by itself. So now that our equation is balanced, let's look at what we have. We know that we have 30 grams of that C3H8, which is propane, and that is our limiting reagent because we are combusting this in air. So oxygen is our excess, this is our limiting reagent, is the propane. So now we need to figure out what is the theoretical maximum amount of carbon dioxide that we could get out of this reaction. So to find our theoretical yield, this is something you've already been doing when you've been doing your mole to mole conversions. So first, remember, I have to get it from grams to moles. So we were told that we started with 30 grams of propane. So 30 grams of propane, and based on this addition right here, we know that 1 mole of propane is about 44.097 grams. I like to leave the full value there so I can get the most accurate answer, and then I like to round at the end. So I put my 1 mole of propane is 44.097. And then from our equation, we know that for every 1 mole of propane, we can get 3 moles of carbon dioxide. So that's where this portion came from. But notice that when we're dealing with the theoretical yield, we want to find out what's the maximum amount of grams of something we can make. So I went ahead and figured out our grams for carbon dioxide. For every 1 mole of carbon dioxide, we have about 44.009 grams of that carbon dioxide. So plug that all into your equation. Make sure everything cancels out except for what you want to solve for at the end, which in this case is our grams of carbon dioxide. And we get 89.82 about grams of carbon dioxide. And I ended up rounding it to these significant figures that match what you were given. So about 90 grams of carbon dioxide can be made. That is our theoretical maximum amount that we can make. But remember, that question told us that we are producing 70 grams of carbon dioxide. So this reaction is not as efficient as we would like it to be. So we want to figure out what's the percentage yield that we can get out of this. The percent yield is pretty straightforward, and you might notice it's very similar to your percent composition. So we have our actual yield, what we actually get out of it, over the theoretical yield that we just calculated, times 100, to get that into a percentage instead of a decimal. So our percent yield in this case is 70 grams. That's what we were told that we were able to make over that 89.82 grams of CO2 that we calculated. And again, I just left it the full number or as close as it could be, and I'll round at the end, times 100%. So our percent yield was about 77.93%, which I rounded to 78%. So notice that under ideal conditions, we will be able to make that our theoretical yield, which would mean that your percent yield would be the exact same. It would be 100%. But that just doesn't happen in the lab. It's not 100%, but you want to get as close to it as possible. So take a look at this, make sure you understand how to do these calculations, and you'll be doing a few examples